One thing that we rely on in order to get good research done is science. We need the scientific method. We need scientists. We need scientists doing a lot of different kinds of things and trying different methods and trying out different lines of inquiry in order to get us all sorts of results, whether we're talking about engineering or chemistry or biology or medicine. We need scientists doing their thing in a way that respects the scientific method. But that's not obviously still happening, or that is under threat from AI. At least so says my guest, Emily Sullivan. She is a senior lecturer of philosophy of science and AI at the University of Edinburgh. She's also the co-director of the Center for Techno-Moral Futures. She's an associate editor for the British Journal for the Philosophy of Science, and she leads the Normative Philosophy of Science Lab. So she seems to be in the know. So when she says that AI is infiltrating the scientific life cycle in a way that potentially undermine scientific inquiry, that should probably give us some pause. Now, as for how it's infiltrating, we'll get to that throughout the conversation. Some of the things that we'll hit, though, is things like, what does the scientific inquiry life cycle look like? From trying to think about what should I be researching? How should I be researching it? What method should I use to engage in that research? How should I write it up? All of that, and not just what should I do, but if I'm a reviewer or if I'm a journal publisher, maybe I should have AI reviewing and doing the peer review instead of having individual other scientists do the peer review. So in all of these places are areas where AI can get into the AI lifecycle and shape how the scientific inquirer does their research or engages in their research, that determines what kinds of questions they ask, or at least deeply influences the kinds of questions they ask. And one, you might worry about this from perspective of bias, hallucinations, that sort of thing. You also might worry about an algorithmic monoculture, as researcher Katie Creel talks about it from Northeastern. We talked about this now a year or two ago on the podcast. Emily brings her research up here. If you only have a handful of models that are shaping scientific research, you don't have 1,000 scientific flowers blooming, you only have a handful. So that could be worrying. So we talk about that research life cycle and the way in which AI is infiltrating it. That said, at the end of the day, what we probably want from scientific inquiry is good results. So maybe I care less about how you figured out how to cure cancer and just that you figured out how to cure cancer. So are we getting wedded to a sort of, conservative approach to science, assuming that we should just use the kinds of methods that we've been using for the past several decades? Or what we should really do is open ourselves up to other ways of engaging in that inquiry, and other ways for that inquiry to be shaped, that is to say, using AI? Or is this really a sort of net bad thing to scientific inquiry? So we talk about all that stuff and more. Okay, my book is also out. You may have heard me read the book aloud on this podcast. You may have heard me just mention it. The book is called The Ethical Nightmare Challenge. It's about the nightmares that are baked into AI, especially agentic AI or AI agents, and what to do about it. You can find that book on Amazon, BarnesandNoble.com, Target, Walmart, blah, 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 blah. If you have any comments, thoughts, trenching criticism of the book or the podcast or anything else, email me at em@reedblackman.com. Okay, let's go talk to Emily. All right, Emily, so lots of people have worries about AI taking over the world. Your view or your concern is slightly narrower than that, but very concerning nonetheless. I think that AI is taking over science. So A, do I have that right? And B, what do you mean? What does it mean for AI to take over science?
Yeah, so AI at least they're trying its darndest to take over science. So what that means is that it's really changing almost all the different aspects of scientific inquiry, from the kinds of questions that people are interested in, the kind of research that gets funded, how people review scientific research, also just like the social structure within scientific teams, how scientific research is written up, and what kinds of scientific research can now even be published in journals because of the impact of AI.
So the way that I'm hearing it is something like this. Hey, Reed, there's something that you might call the scientific research life cycle that goes from the ideas in the head of the researchers to what questions they ultimately land on, to the methods that they employ, to how they execute, to how they interpret the data, to what gets published, why it gets published, and where it gets published. And that life cycle is infiltrated, if you like, by AI at each stage. Is that a fair summary?
Yeah, that's right. Yeah.
All right, so let's go through the life cycle. Let's start at the beginning. What? So here's the way things could go. I'm a scientist. I see the publications that are out there, the research that's out there. I take the classes that I do. I'm with the peers that I'm with, the colleagues, whether they're professors, grad students, whatever. And I get a hunch and I formulate some questions. Then I think, okay, I don't see anyone answering that question with any research out there now. I'm going to go do this research. What do we imagine here? What's the issue? That we go talk to AI and say, hey, what should I research? How is it influencing? How is it influencing people's research questions? And secondly, is it necessarily influencing it in a bad way?
Yeah, so it's really going to largely depend on the domain. But even just this kind of scenario that you're talking about, yeah, people are going to, Claude and asking about what kinds of scientific questions should I be researching, or like what kinds of scientific questions are likely to be published in a certain journal, and
Oh,
then
man.
having that discussion with Claude instead of their supervisor. So that's that kind of interaction that you're talking about. But in other domains too, it's like a shift from trying to look at problems that can be solved by big data, right? So it's a reframing of even the kinds of methods we should be using, right? So we have all this data, we have these powerful tools now that can get interesting results out of data. We've had 2 Nobel Prize recently for models used by AI in this way, like AlphaFold, for example. And so now people are rushing to see, oh, if I can just collect all this data, maybe I can just solve scientific questions that are narrowly defined around big data questions.
I see. So there's 2 ways that things are going, at least potentially sideways, or at least 2 ways AI is influencing it. One is something like, the first one is just people don't come up with their own research questions, Claude or some other LLM does it, which is just depressing. Isn't that just depressing? Because I don't know, as a former researcher myself, I think that one thing that was so wonderful about the research was that I got to be guided by what I find intrinsically interesting and what I want to find out, as opposed to these sort of external, I don't know, trophies or whatever, like publications. There's a real job market, blah, blah, but still it's depressing. And then one question there, is it any different than when an advisor says, you should really look over at this area? People are not talking enough about X. You should go look at X. So do we care? Is it sort of an aversion to AI? Is it an aversion to guidance as such? Which one is it? Let's start there. I go to the questions, of course.
Yeah, so I think part of it, I mean, it is, I feel a kind of like sense of like alienation from science just by interacting with Claude over just thinking about it on my own. So I do philosophy, which is a different kind of science.
Yeah.
But even I've talked to some philosophers that I respect who are now turning to these models to help them think about arguments and think about ideas. And that's the whole point of me liking philosophy, is that that's the part about philosophy I enjoy the most. So why are we
Figuring it out.
Yeah. Why are we offloading the
crazy.
most enjoyable parts of our research to a tool? So I think that there is this kind of human element to science that often gets overlooked, or at least now in the kind of hype cycles where we're just obsessed with output or the results, when there's this whole other aspect of science that is human and social. And I think that we need to hold on to those. But then what is the problem if we are taking a kind of results-oriented look? What is the problem with using AI for helping us think about important research questions? I think that there's, just like anything else, like there could be individual cases where it's very benign, right? But once you start to do this at scale, right, then you get these biases throughout these kinds of models, right, that Katie Curl calls like an algorithmic monoculture, where you can't escape the kinds of methodological biases of these models, even if you're using ChatGPT over Claude or some other model.
Sure.
And you'll have this kind of homogenation of science, whereas in the old model, you might get idiosyncratic research avenues at different research schools across the globe. And
different schools are known for different sort of fields of thought, or fields of thought. Is that the expression?
Yeah, or
Something
methods,
like
or kinds of questions that they think are important. And part of the reason why science has been so successful is this kind of let 1,000 flowers bloom, and we'll see what ends up being successful. But if now we don't let those 1,000 flowers bloom, but only 2 flowers, right, then we might in the long run run into some issues there.
Yeah, that's depressing. Yeah, also former philosophy professor, and yeah, UCLA was known for doing something different from Northwestern, was known for doing something different from Harvard, was known for doing something different from Rutgers, etc. They all had camps of thought or whatever, and right, that seems like a good way of going about things. But if I don't know, so I don't want to. I guess my question is something like, how do we do empirical research here on this front? Because we have an empirical claim before us. It's something like, if AI gets more involved in how scientific researchers, or frankly, any kind of researcher, goes about formulating their research questions, areas of inquiry, paths of investigation, then, and there are relatively few quantity of models around. There's Claude, there's ChatGPT, there's Gemini, but there's certainly not 1,000 flowers to bloom. There's just a handful. Then we'll wind up with a more homogeneous investigative culture, which means that they'll be skewed, if you like, one way rather than the other way. And so we're going to be blinded to the things that we would have discovered otherwise. I guess that's the critique, right? And I guess I just don't know how to think about the probability of that thing happening.
Oh, yeah. So I think that there's plenty of research done in other domains in terms of having this kind of algorithmic monoculture. So I think that why wouldn't it apply to domains of inquiry as science? I think the other reason is just because these models, the way that they operate, at least now, aren't necessarily grounded in scientific methods and inquiry, right? So AlphaFold is one thing, right? So AlphaFold is not a large language model.
Right.
So it was really...
That's the protein folding.
Yeah, the protein folding
AI,
model,
right,
yeah. So that was built with a lot of domain expertise, and it was very tailor-suited for that particular problem. But with large language models, they are really just giving what's the most probable answer to the next token prediction, right? So that you can do some fine-tuning here and there, but at the end of the day, you're not going to get out of that probability distribution of what's most probable. And sometimes, or somewhat often, right, some of these models can just output nonsense, right?
Yeah.
So it's not just that...
False stuff, yeah.
Yeah, so it's not just that you have a problem of homogenation, but you also have this problem of introducing false ideas into the scientific method that wouldn't have otherwise been introduced. So I think it's fairly likely, right, that this will end up being a problem. There's another problem too,
I just want
to,
before we get to the other problem, keep it in your head, but I just want to note, I was at a coffee shop literally yesterday, just doing some work or whatever, and I overheard these two people talking, and they were clearly doctors talking about, or maybe they were med students or something along those lines, but they were having a conversation with each other and with an LLM in the mix, I don't know which one because I couldn't see their computer screen, about something like likely causes of this disease or that disease, and it was, one of them would say something and then the other would confer the LLM and they'd say, oh no, actually that's not right because blah, blah, blah. I'd say, oh, that's surprising because blah, blah. And they were treating this LLM as a kind of equal thought partner in thinking through these medical diagnoses. And again, I don't know if they're med students or they're board certified doctors, but they were engaged in a kind of inquiry or at least reflecting certain scientific conclusions that are the result of this completely non-specialized, I assume they're not using I think they were using a general, I don't know, but assuming they were, it's not specialized in the way that, not AlphaGo, what is it?
AlphaFold.
AlphaFold, the combining things. Yeah, it's not specialized in the ways. I don't know, that just strikes me as one example in which maybe that's where the scientific literature is today, maybe that's not where it is tomorrow, maybe when they trained the LLM, it didn't pay attention to certain areas where certain publications or something along those lines, or there's just various random explanations for why some studies get surfaced and while other studies don't get surfaced. So you can see your bias generating that way. And if all of the med students or all the doctors are engaged in a similar kind of activity, or at least a sufficient quantity of them, you could see how their scientific deliberations or their medical, in this case, their sort of medical deliberations are going to get skewed in one way and in a homogenous way, to your point.
Yeah, I think that this example calls for a very important distinction of how we're using the models. So in this context, we were talking about using it as like the first stage of inquiry in science. So thinking about what kinds of questions we should be then doing other research on, right? So there's already the sense when we're engaged in that you might come up with bad questions, right? So the large language model might give you some bad questions to research and you can navigate it. There's also less risk of mistakes, right? Because science always, when you're actually then doing the research, you end up not being right. And that's part of the scientific method, is this kind of
Sure.
collection of error. But if you're using these models, maybe, I don't know what these people were doing, these
Yeah.
doctors were doing in the cafe, but if they're using them not as a kind of bounce point for doing future research, but as an equal co-deliberative partner to then deploy that knowledge in a real-world setting, now you're not using it that way. You're using it
Yes. I've
as
jumped the life cycle
we
down
jumped
yeah,
down
yeah.
to the life cycle. And I
Yeah.
think that distinction is important. And the way that I like to think about these models is that I like to think of them as a kind of toy model. And by thinking of them as if they're toy models, then we can see why it might be perfectly fine in lots of contexts to have this kind of, to use the models in the first step of inquiry, even though it might lead to some of these problems of homogenation, but that we definitely shouldn't be using them in the context of deployment in a kind of medical context, because the answers that they're giving us, we should treat with extreme epistemic caution because they're just, toys.
Yeah, first we got to teach the phrase epistemic caution. That's a heavy enough lift. Okay, we'll go back to that life cycle bit, that part of the life cycle. Oh, so there was another problem that you wanted to say that I interrupted you.
Oh, yeah. So that problem was a kind of long-term problem. So there's some evidence that when you train these large language models on generative data, so text that was generated by a large language model, you get
Yep.
rapid model decline. So in the long run, if all of science, so the kinds of questions that are being studied, those studies are being written up with the help of large language models, then you no longer get the kind of input needed to these models to actually improve them, and then you actually end up getting model decline. Yeah.
So now we've gone a little bit down the life cycle again, right? Because now we've gotten to the point of publication.
Yeah.
And so the thing is finally published, but the thing is that it was written in no small part by a large language model. And if there's model degradation, then whatever the outputs of the LLM are going to be, it's going to be some way or other not truly faithful to the research or to the, let's just suppose, the actual discoveries that were made. It's going to outputs that's not true to those discoveries.
Yeah, so it's a problem of sustainability, right? It's one where it might seem like right now it's fine to use large language models and the first step of inquiry, but we're going to get into this position point where we're actually teetering on crisis if people end up doing this to a large degree, because the whole kind of scientific system might end up collapsing in some way.
Yeah, that wouldn't be great. That wouldn't be great. So to what extent, though, okay, so let me ask, I could see the source of the problems, or I could see the nature of the problems. How do you think about something like who's responsible for solving for these problems, or what can be done to solve for these problems? Do you think of it as primarily it's for the individual users? Hey, don't consult, or for the instructions that research institutions give, don't use AI to generate your ideas for research, blah, blah, blah. Is it that the kind of thing that you want to see? Is it that you want to see the AI developers creating those AIs in a different way, such that when they're employed in this kind of way, they're built to somehow encourage 1,000 flowers to bloom? Maybe it's instead it says, well, you should pursue this avenue of research, or this might be something like, here are 3 different areas that you might think about depending on what you find interesting. Could be this, that, or the other thing. So is it maybe how much of the solution lies in how the LLMs are created, or the personality, quote unquote, personality that's given to the LLMs? Yeah, I'll just stop there.
Yeah, I think when we're talking about issues of responsibility, they're very complex issues. And I tend to, and a lot of these problems are problems of at scale or collective action problems. So I do think that we need to rethink about what scientific integrity means now in the face of AI, and that will involve certain disciplines coming up with their own standards and certain professional bodies coming up with their own standards. So I think there is a role for personal responsibility here, but people need clear guidelines, right? So right now it's just a mess where different journals have different AI guidelines, different AI policies. Universities themselves are now putting out different AI policies in terms of individuals and what kinds of research is legitimate or not legitimate with AI use. And then funding bodies also have different policies, right? And it's really hard for any individual person to navigate all those
Yeah,
conflicting
absolutely.
different policies. And I think that and one of the things with AI isn't necessarily that the problems are completely new, but it's just pouring gasoline on a fire,
Yeah.
right? So there's always been these incentive structures of science that are problematic. So going after metrics instead of the knowledge in itself, right? Peer review has been under crisis for a long time, right?
Yeah.
But AI is just pouring gasoline, so then we can see these problems more clearly.
Yeah. So let me try to push back a little bit, or imagine how somebody might reply to all this who's a cheerleader for AI. And I would put something like philosophy to the side, where we're not exactly a results-oriented discipline. It's not as though you could see that it works. That's not the sort of thing that philosophers do. So if we're talking about natural sciences, and I might say something like, hey, look, whatever, the proof is in the pudding. You can wax poetic about the love of inquiry and humanity and research and blah, blah, blah. It's all good and well. But at the end of the day, what I want is people cured of cancer. I want new diseases solved for. I want deeper understanding into, I don't know, biological systems so that we can create the appropriate strategies for sustaining, say, ecosystems, environmental ecosystems, something along those lines. And look, there is a way in which, yes, there's perhaps not enough different models, but we can solve for that kind of thing by having different personality or something. You said that there's lots of different bodies that have different policies about how AI is used and when it's used and where you can use it, that sort of thing. So there's also a kind of experimentation there, what kinds of policies work or don't work or hinder innovation or research or discovery. And let's just see why be so pessimistic? Why not think, look, we're going to find out whether AI has these detrimental consequences. And we may find out that it has amazing results, that we're finding cures for diseases at a faster pace than ever, that we're doing better biology, better chemistry, better, et cetera, et cetera. And yes, maybe there's a little bit, and we touched on this issue briefly. Yes, maybe there's a little bit of, I have a hammer so everything looks like a nail. So everything comes about analyzing big data instead of other ways of doing science. Again, if we get the results, and we may well, all this worrying about the process and the integrity of science and all that turns out to be, I don't know, overly conservative.
Yeah, so I will get a few things to say about that. So the first is that I definitely don't want to say that we shouldn't be deploying AI at all in science. So I definitely don't want to say that. I definitely think that there's lots of potential for AI to really help in a lot of areas, right? So we've been talked about AlphaFold, for example, right? So AlphaFold is, of course, it has its own problems, but it was a great scientific achievement, and people use this model now in their day-to-day workflow, and it's really helped make certain advancements, right? So I definitely don't want to say that we shouldn't be using AI. I think we need to then go back to this concept I was talking about before about AI models being a kind of toy model, but also another concept for how we should think about when models are going to help us get to greater scientific progress or understanding versus the cases in which they don't. And so that's by thinking about the ways in which models are actually going to be grounded to the target that they're studying, right? And so I call this link uncertainty. So with AlphaFold...
Sorry, what was that word?
Link uncertainty.
Link?
Link uncertainty, yeah. So
okay.
That with a lot of AI models, we come with this high degree of link uncertainty, this high degree of uncertainty whether or not the model is actually giving us insight into the target that it aims to give us insight into. So with AlphaFold, there was a lot of domain expertise going into that model. So we have lots of reasons to think that the model there is a strong link between the model and the target of proteins and how they fold.
Sure.
Right? But if we're just like spinning up an AI model out of the blue for trying to find new predictive indicators for certain diseases, and we just throw a bunch of data at it and just see what comes out, in that case, we have a high degree of link uncertainty where we just threw a bunch of data at something. We have no idea whether the kinds of risk factors the model is picking out for this medical issue is actually tracking the target at all, or if it's just a
Yeah.
confounding factor.
Yeah.
So when we're thinking about large language models, the way that they're trained could be fairly divorced from the target phenomena that they're
Sure.
seeking to capture, so that we have this high degree of link uncertainty, and then we should just be treating it as a kind of toy model. So in my work, I push towards researchers to think about how they might reduce the link uncertainty of their machine learning models so that we can then be more trusting in their results.
So it's something like, to put it slightly differently, I think what you want is you want tailored models. You want customized models to domains of inquiry.
Sure, yeah. Yeah, that's a nice way to put it. This kind of push towards having some kind of general AI scientist, right?
Yeah.
Like, why? So that's the one question is like, why do we need this kind
Yeah.
of general AI scientist? But also,
Yeah.
I'm skeptical that project will actually succeed instead of building these kind of bespoke models tailored to
Yeah.
particular purposes that reduce that link uncertainty between the model and the target that they're trying to capture.
So here's, I don't know if this is anecdotal. I guess it's not anecdotal. But so it's two things about why we might not want the customized model. One is, and this is going back to 2023 maybe, early 2023, I was talking to a guy named Peter Lee. He's a lead researcher in healthcare at Microsoft. And we were talking about, and he's a PhD, he was at Carnegie Mellon, smart guy, has a team of researchers at Microsoft. And they were trying to figure out which is better at differential diagnoses. Is it the general purpose LLM, or is it the one that's specifically made for medical diagnoses in particular? And it turns out that the more general model was better, so that's the counterintuitive result. You would think that the specialized one would do better in medical contexts. It turns out that wasn't the case. Now, again, this was 2023. I don't think the term RAG existed yet, or I'm not sure that people weren't talking about fine-tuning and RAG and adapters and stuff like that, the way that they make LLMs were customized today as opposed to the way that they may have done it 3 years ago or whatever it was, 2-3 years ago. So one, it just strikes me as it's an empirical question as to whether the general models, for whatever reason, turn out to be better than the specialized models. I think the idea is supposed to be something like they're just drawing from so many more points of connection, more data, blah, 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 that it somehow makes it more general, reliable. And anyway, that's one note. The second thing, and again, this is empirical speculation on my part, is it might be the case that one of the ways to make scientific advances is by connecting things that we didn't see connected before, by connecting dots that we didn't connect before. For instance, it's very hard for doctors, let's say if we're talking about healthcare, there's geneticists, there's pediatricians, there's oncologists, there's rheumatologists, there's blah, blah, blah. These are all the specialties, right? And no one is a specialty at all of those things. And so one thing that you might think is, well, what you don't want is just AI that specializes in rheumatology and specializes in genetics and specializes, because you want a kind of AI that can draw points of connection between those things, notice at a bare minimum correlations between all those data points across all those pieces of research, across all those areas of expertise that no human could pick up on or is very unlikely to pick up on. And then if you expand that broader and you say, you don't just want it to be healthcare that do the dot connecting, we don't just want the dot connecting within healthcare and all the specialties in healthcare, but we want to draw or connect dots between healthcare and biology and chemistry and physics and blah, blah. And so that's why we don't want to get too specialized here, because if we get too specialized, then we're going to miss out on the connections that AI could see that we can't.
Yeah, good. So I think the idea that it was like an empirical question, like which models will do better at certain kinds of tasks, right? So again, I wasn't trying to say that a general purpose model in virtue of being general purpose wouldn't be necessarily a good model that has low link uncertainty depending on other aspects of the model, right? So depending on the kind of training data, the way that it arrives at its outputs, and there are other ways in which we might reduce the link uncertainty there.
Yeah.
But I think when we also need to think about, though, is, well, what accuracy means in these contexts. And that is often a value-laden question. So there's always going to be these trade-offs between false positives and false negatives. And when we think about accuracy, we need to think about what is this trade-off here that we're willing to accept in a given domain. And when we're thinking about medical contexts in particular, right, we might answer that question differently in different contexts. And maybe the general purpose model might just have better types of outcomes compared to the more specific one. So we can't so one thing I think we need to be more critical about is, if we are just looking at specifically results-oriented framework, we need to be careful to think about what is the kind of accuracy that they're talking about and what kind of accuracy do we actually want in a particular context. And then think about the kinds of models that can help us achieve the results we want and how we might reduce that link uncertainty there. Yeah, I think what you say, like the pitch for why we should have AGI, right? We can just see all these connections and that we might otherwise not have. Sure, that sounds nice, but I think that, again, going back to this idea of letting 1,000 flowers bloom here, there's something about it that, I don't know, is scary in a way that there's only like one AGI, right, that is finding all these connections instead of having a kind of checks and balances. So I think part of it is to think about how science should be diverse in its modeling techniques, right? So maybe some aspect of science can be looking at overlooked patterns across disciplines, but that we still need the kind of scientific inquiry that's really just domain specific, looking at really like human interest questions driven by curiosity in a very narrow sense, and that we need to also fight for that.
Yeah. I think that's totally fair. I don't think it necessarily has to be AGI. It could just be an LLM or something like that that's really capable. So I guess I want to, maybe this is too big of a question or doesn't admit of a straightforward enough answer, but I guess I want to understand more about the level of threat here to science that we face because of AI. Part of the reason that I have trouble thinking about it is I have trouble thinking about what to compare it to. So we touched on this a little bit already, but your advisor guides you in a certain way, the university at which you do research guides you in a certain way, the people who hold the purse strings for research grants direct research in a certain kind of way. And so it's not, if the comparison is a researcher, financially independent, free of undue external influence, fighting the good fight of scientific inquiry, yeah, AI seems really shitty. But if I compare it to very financially independent scientific researcher, very much subject to various kinds of undue influence, whether it's the university that they're at, or the blind referees reading their report, or the editor at the journal, or the holder of the purse strings of the grant, or the et cetera, et cetera. What's in vogue now in science and what's in not, right? Every discipline has things that are just, for whatever reason, it's just in style. And so what's deemed quote unquote interesting or worthwhile is, it's part scientific, but it's also part, I don't know, sociological or something like that, for lack of a better term. So that's why, so when I zoom out and I see it's not the lone researcher just fighting the good fight, it is this set of researchers that are embedded in a very complicated world. How much is the AI disruptive to that in a bad way? Is it just one more bad thing in the mix? Is it an outsized bad thing in the mix? Is it, whatever, I'll stop there. I just don't know. Should the light be blinking red or yellow? I suppose that's another way of asking the question. How big is the threat? How imminent?
Yeah, so I see three big threats. The first threat I think we've talked about a lot already, which is this threat of us over-trusting models because they seem better than they are, especially those doctors. Talking with a large language model is like really scary to me. But so that's the first threat, is that people just overestimate the power of these models at this moment.
Yeah.
The second threat comes from de-skilling. So right now, we still have this kind of sweet spot where there's a lot of people who have extraordinary scientific expertise, and they can use these models to help them, and a large part because of their existing expertise and being able to know pretty quickly when the model is going awry and when it's like leading on the right track. Right. But once we start relying on these models more and more, people won't have developed that expertise to be able to notice the difference. So there's now some new research coming out that relying on large language models is a kind of like cognitive offloading and leads to brain rot, right? So there's some evidence that there is this kind of de-skilling. So this threat is more of a longer term threat, right? And I am very concerned about it in scientific education. So this is, I guess, even before the pipeline that we talked about, which is just, learning about how to do science. So there, I'm much more, we should make sure that people still are learning fundamentals and not relying too much on AI. But then once you're, an expert scientific researcher, of course, it makes sense that you would then use these models in a way that makes sense for the research questions you're asking.
Yeah, I like to tell people that AI is best used by experts, because if I use it in a AI context or a AI ethics context or a philosophy context, I can immediately spot bad answers. I can spot bullshit. It's easy. And no, that's going down the wrong path. That's not going to be, but it's because I'm an expert there. Whereas if it gives me, I don't know, if I pull out something random, like a marketing plan, I don't know anything about marketing. And so is that a good marketing plan? I don't have the tools with which to assess it. And so it's only genuinely useful to me, I find, when I've got good instincts that are the result of training and experience by which I can say no to the thing. But if I don't have it, forget it. And so it's the same thing with scientific inquiry. I take it as your point. Something like, if you're not already an expert, you don't know how to spot bullshit. You don't know how to spot going down the wrong path. You don't know how to say no to the thing, or when it's just clearly going down the wrong path.
Yeah, or even just to think critically, right? So part of being a scientific researcher is thinking critically about the kinds of problems you're investigating. And if you are now offloading the critical thinking task, then you're not gonna build that muscle.
Yeah. I want to air my misanthropy. I think that's what I want to air. Something like that. I think that, especially when philosophers talk about this sort of thing, they talk about, they're not engaged in critical thinking. They're not thinking for themselves. They're taking on the AI's word, blah, blah. Philosophers typically envision themselves as interacting with these things. And we think, everyone let's say in the natural sciences is engaged in a great deal of skepticism. I feel like one of the biggest tools that philosophers have at their disposal is habitual skepticism. Just, I don't buy it. I don't buy it. And I don't know if that level of skepticism is present in a lot of researchers. The replication crisis makes me think maybe not. The replication crisis, at least in the social sciences, makes me think maybe skepticism isn't sufficiently robust there. I also think about things like p-hacking, right? Trying to figure out in the set of data, how can we show on paper anyway, statistically significant results such that we can get a publication out of it. And on the one hand, I'm on board with these claims about AIs can erode cognitive abilities and offloading. And then part of me thinks, I don't know, are they doing that much offloading? Because are they doing that much thinking for themselves to begin with? And this is not a scientific claim I'm making. It's just, again, airing my kind of suspicion of humanity's intellectual independence.
Yeah, I have an anecdote from a physicist. I was at a physics workshop about AI and physics. And the one physicist was talking about how a lot of his most recent PhDs were getting hired by Anthropic. So these are like physicist PhDs. And then he asked them like why? And they said that physicists don't trust the data.
Okay.
Right. So there are people, like all sorts of domains of scientists, they do have this knee-jerk reaction of skepticism. So it's not just philosophy. So the kinds of problems
for sure,
of the replication crisis, I think his point isn't about the virtues of skepticism, but more about these kinds of social structural incentives of science that can't be
Mhm.
solved by individuals having virtue, right? But by more
Yep.
structural approaches, for like pre-registration of your studies and things like that.
That's interesting. Say more about that. So you're pointing something like, I like this point a lot, which is something like, look, there is skepticism shared by a great many disciplines, arguably all of them, insofar as they're engaged in their sort of intellectual pursuits. But to the extent that people tend not to be skeptical, the best explanation is not a lack of the virtue of skepticism, but something like social structures that actively undermine that skepticism. Is that right?
Yeah. So yeah, maybe that's an empirical question. I'm not sure, but I think that I think, I think the run-of-the-mill scientist is very skeptical, has a skeptical attitude. I think that people in general have a kind of underlying skeptical attitude. I think that if we're thinking about large language models in particular, they are trained to make you believe them, right? So they're
For
trained
sure.
to exploit certain cognitive biases that we have away from skepticism because we have other innate human biases thinking that we personally have good ideas, right? And so
Yep,
large
for
language
sure.
models are sycophants, right? They are going to
Yeah,
agree with
right.
you no matter what.
Yeah, what a
Um,
brilliant idea.
yeah, so going back to you asked before, is there a way to just change how some of these models are, like how they're trained, and if we change the way they're allowed to be deployed in certain contexts? I don't think that will necessarily solve all the problems that we're talking about here, but I think
Yeah,
it's important to think about ways in which models can be aligned to be better and to cultivate better
yeah.
avenues of inquiry. Right now, they're just aligned with helpfulness, harmlessness,
Hmm.
and honesty, right? Those None of those are about honesty isn't necessarily about truth tracking, right?
For sure. It's
Yeah.
something like sincerity.
Yeah, yeah. So I think there's a lot to say about those particular values, but if we think about that there are other kinds of epistemic values that we want to have these models align for in order to do good science, right? Then we definitely need to go beyond those three and need to go
Yeah,
towards values of constructing these models to be about skepticism, about enabling understanding, and other
yeah.
values for science.
So there's something behind the question that I just asked about it's not that they lack the virtues of skepticism, but it's something like they don't have the right kinds of structures around
Mm.
them. There's a way in which, so you said you have three main problems. I remember two of them. I don't know if you even got to the third one.
Yeah, I
One
didn't get
was
to it.
something like, one was automation bias. Like they're just
Yeah.
gonna defer to the AIs. The second was de-skilling. And those are not just, you're going to mention the third one in a second, but what I was trying to get at was those are very general problems, right? Those aren't problems that are specific to scientific inquiry. Those are problems that we have whether you're a lawyer or a doctor
Mhm.
or
Yeah,
whatever.
sure.
It's just general problems with LLMs. And then we had this sort of question, well, what do we do about those things? And I think that when we ask that question, we're usually asking it in a very broad way. Like I asked it in a very broad way. I said, should it be up to the AI companies to do something or other about it? Should it be up to the research institution to do something or other about it? And I wonder if, based on the kinds of things that you were saying about what encourages the right kind of skepticism or executing on that skepticism or whatever it is, whether what we need to do about it, about those things, descaling, automation bias, and perhaps whatever your third thing is, doesn't admit of a general answer or doesn't admit only of a general answer, but also needs something like, no, here's the things that we need to do specifically in scientific inquiry to combat automation bias and descaling.
Yeah, I think there are broader structural things we can do. So in terms of descaling, I mean, it just surprises me how quickly universities went towards gravitating towards the use of these models and integrating them in their systems, because I think that it's a direct threat to their funding model. But anyway, but even if it wasn't, having more structural procedures in place so that students don't actually learn skills without AI interference, I think can go towards somewhat towards the process of or alleviating the worries of deskilling. There are probably other creative structural solutions to
Yeah.
some of these problems, right? Having age limits on who can use these systems, for example, right, might help with that kind of problem. But I think really the kind of point that I wanted to make was that I think a lot of times we come back to this idea of people just need to take personal responsibility, or people just need to
Yeah.
use the systems correctly, when
hmm
there's also, if we put our minds to it, creative solutions to more structural problems and more collective action problems.
Okay, the third thing. What was the third thing that you're worried about?
Yeah, so the third thing I think which is unique to science, is
Ah,
peer review
yeah,
and
I hate peer review.
journal
Hate it.
publications. Yeah.
Okay, go on.
Yeah. So all these journals are just inundated now with AI generated papers.
Wonderful.
And right now we're just like playing catch up, right? So you have certain medical journals now even saying you can't publish research with publicly available data, because if the data is publicly available, then it's more likely that it was just generated by a large language model or by generative AI tool.
Interesting.
Archive, one of the biggest depositories of academic research, has stopped, especially Archive in computer science, has stopped accepting any position paper that hasn't already been peer reviewed for publication, because they're just just full of AI generated papers, right? Because AI can
Yeah.
now generate position papers, which are more philosophical like papers
Sure.
anyway, right?
Sure.
So now you have this kind of blocking off of ways of doing research and moving science forward, that because of this like inundation of certain kinds of AI generated research, and that we just don't have the tools in peer review to stamp that out, because we don't have the capacity for in peer review.
Yeah.
But then also people engaged in peer review might be, there's all these stories now of people highly suspecting that their paper has been reviewed by AI, right? So I think that this is a huge
A mess.
crisis moment, right? Because, and some people argue, right, we should be using AI to solve the problem. So now we can just use AI to review
Yeah.
our papers. And then if those papers are also generated by AI, then that's fine too. If it accepts it, then it's good work anyway.
Okay. So the problem here is, let me put it slightly stronger. Tell me if this is not what you're driving at. Look, we've got decades of peer-reviewed research being the gold standard for what counts as good research. It has driven whatever, all the technological innovations and revolutions that we've seen in the past decades. It has in no small part been literally or metaphorically funded by the peer review process. That's how we get really good work done. And we're now at a point at which that peer-reviewed system is breaking down on both sides, both by the people submitting the papers and the quote-unquote reviewers reviewing, because it could be AI on both sides. And we don't have a tremendously good reason for thinking that the AIs are good, particularly good at either side of those things. And so what we face is the potential collapse of a system that worked really well for vetting research. And now it's just going to be a free-for-all. And I think to some people, they might hear, oh, that's great, we're going to democratize research. But to me, it just sounds like a Reddit thread where the success of research is a function of how many thumbs ups it gets. I've never actually been on Reddit or used it, so I don't have to get, did they do thumbs up? Anyway, whatever. It's going to be more like social media as opposed to highly qualified experts vetting research. And so it's like it's an epistemic crisis.
Yeah, for sure. So that issue of model decline I spoke about earlier, I think comes back here in this context of peer review. But also, peer review was never meant to be able to detect like wide-scale fraud, right? Of course, there might be some signs that data has been fabricated in various ways, but normally the kinds of fraud cases that you've seen in psychology and things like this took many years for those cases to be brought forward. And if we're relying now on AI to write papers, it's hard. Peer review isn't going to be able to necessarily be able to recognize whether the paper was generated by AI and whether the data is fabricated. So that's one problem. And then the second problem is that if we then have AI reviewing these papers, at least tools right now, they're not going to necessarily do also at crunching the numbers to see if the studies are accurate. They're not very good calculators, right? Because they're not actually doing math behind the scenes. And it's actually a really hard problem that these companies are working on, is one to recognize when a question is a math question and send it to a different module that can actually then do math, right? And having AI review the papers really introduces this problem of homogenation and making and really just gaming the system in a way that probably goes further and further away from truth trackfulness instead of just these arbitrary proxies. There's already that in science where you try to write papers for these like arbitrary proxies of reviewer two, but it's going to be even more dramatic if it's an AI that we're trying to beat.
Yeah, this is no good. Now I'm worried. Yeah, this is not good. It's not bad. This is bad.
So on the positive note, I think that a lot of people share these sentiments, right? So a lot of the journals, most highly regarded journals now, right, they don't allow reviewers to be submitting their papers to AI tools and generating AI reviews, and they don't want that to happen, right? So I think that scientists and the scientific community is like pushing back on some of these problems. So I think there is a kind of light at the end of the tunnel here. But again, the AI hype bros are relentless. So we got to make sure that we keep pushing the counter narratives.
It's not just this. Maybe this is just my imagination running wild, but it's not just the hype bros. There will be some publications that do allow it, and they'll market themselves as, we are results oriented. We want the right answers. We're not gatekeepers to knowledge. There's a whole spin you can put about it's good to have AI, and then people who don't want to wait 3 months, 4 months, 5 months, a year, whatever, to get their damn paper reviewed, let alone if they get to revise and resubmit. Now, forget it. We're looking at a year. They just need a publication. They need publications to get a job or whatever it is. And eventually it'll just become a thing that you do until it becomes normal. So I just think it might, if you like, flood the intellectual marketplace until it gains sufficient legitimacy. That's it. And then the other ones, they'll be the last remaining stalwarts, but they'll be few and far between, and there won't be enough to undergird or support the community of researchers as a whole. And so eventually...
I think that's the risk, right? And I think that there's an opportunity for professional bodies to take a stand on what values they stand for and what good science means, right? And we also have an opportunity for different state actors in terms of their funding bodies to also take a stand on what they think what good science means and to push these kind of standards. We saw this with the open access movement, right? So these funders and state actors had pushed for open access such that they changed the incentives, where if you don't publish open access in the UK, then your publication isn't counted for the ref and you don't get state funding, things like this. So we do have an opportunity to change these kinds of social structures for the good. And open access isn't about scientific integrity, right? You can still do good science without open access, right? But it's just that we thought that this was a particularly good value for science to have. And if there are these good values for science that we want to keep, we have an opportunity to say to those who are building these big tech models that you need to align them with these values or you can't do business here.
All right. Here's to lofty ideals. Sounds great. Sign me up. All right, Emily, this has been fascinating and slightly terrifying at the end. So thank you so much for coming on and discussing these things.
Yeah, it's fun.
All right.
Yeah.
Thanks.
Okay.
Thanks everyone for listening. I hope you enjoyed the episode, and I want to thank a few people who make this all possible. Delano Alexander, he's my producer. He does such an amazing job on everything that he touches. Garrett Lang is the sound engineer. That's honestly, he's too good for me. Athmia Jairam has joined us recently. He's helping us find the best guests to bring onto this podcast. And Ashley Wassilenko helps us organize all this, get people on the schedule, get people's bios, headshots, and really keeps the train on the track. So thanks, guys. Really appreciate all the hard work you do.